We will continue with the last speaker for today, Monica Borunda from Mexico, and she will talk about the technical assessment of small-scale wind power for residential use in Mexico. A Bayesian intelligence. Are you there?
Yes, hello, good afternoon.
Hello.
I'm here.
Yeah, welcome.
Yes. Thank you so much, and thank you so much for the invitation to this interesting conference. And indeed, I will talk to you about one of my latest work, which is technical assessment of small wind power for residential use in Mexico, using a Bayesian intelligence approach. So this work has been published in PLOS ONE, and I provide you the reference in case you want to look at it with more detail. And it was done in collaboration with more colleagues. Some of them are currently attending the conference. And they are Javier de la Cruz, which also belongs to CONACYT-INEEL. There is also Raul Garduño, which I think he's around as well. And also Dr. Anne Nicholson from Monash University in Australia. So the contents of this talk are the following. First, I will give you a motivation for working on this topic, and then I will present you some highlights about the wind resource and its intermittent nature. I will proceed by describing important facts about the residential energy sector in Mexico, and then I will show you our system for assessment of wind power for residential use to avoid expensive electricity bills. And finally, I will close up my presentation with conclusions. So why we are working on this? Because we all are going towards a clean planet. And as you know, there are three main facts that, that currently are happening. First of all, we have the global warming, and it is an emergency that we have to deal with it. And then there is also a constantly increase on the energy demand, and it is not stopping, so it keeps increasing. And on the other hand, the power supply by fossil fuels is reaching a limit. So given these facts, it seems that one solution is to use renewable energy as the main source of energy. Between renewable energies, we have wind energy, and all of us are working on that. And you know, the positive things about this source of energy is, first of all, that it is an infinite source of energy, and then, very important, it has low emission of polluting gases. But the bad point about it is that it is an intermittent source, contrary to fossil fuels, and it also needs more expensive technology to profit it compared to fossil fuels. So I know that Denmark is very good, and it is at the top 10 countries with wind power generation. But what about Mexico? So here I show you a graph from CENER, which is the Secretary of Energy in Mexico, and it shows the electricity production by technology. Here you can see how much of the percentage is produced given a different technology. And in particular, we see from the years 2004 till 2013 that wind energy only amounts to 0.7% of the total production. From this 0.7, only 0.63 comes from private companies and 0.07 for public. So it is very small amount up to this 2013. Nowadays, I think you can see it, barely see it, but nowadays, the wind power generation capacity in Mexico is a bit bigger than 1 gigawatt. But I have good news, because the government right now, even though we have a difficult situation, but the government is boosting the use of renewable energy. And that's why we're working, me and my colleagues are working in this topic. So how is the wind resource in Mexico? Well, here I show you this map, which is called the Atlas Wind Map of Mexico. And you can see the wind resource in my country. It starts with pink color, which amounts for small wind speeds. And then as the color changes to blue, green, yellow, and red, the wind speed is increasing. So for example, here you have this area with high wind speed, and this corresponds to Istmo de Tehuantepec. Perhaps some of you know about it. Here there is also an area with high wind speed, but that's it. The rest of the areas here correspond to yellow, green, and blue, and these are like good, moderate, or even poor wind around the area. So we are focusing on using these small scale wind power technologies to profit of this moderate and good wind resource that is all over our country. Now, let me highlight some facts about wind energy and its statistical nature, which are very important for this work. And first, you all know that wind speed is constantly changing. And therefore, that's why we say that it has an intermittent nature. So if it is constantly changing, one must provide a statistical treatment of the data and the resource here. And what one usually does, as you well know, one measures the wind speed and one plots a histogram of the frequencies of appearance of each wind speed. Then the histogram is usually normalized, and then in order to treat it analytically, one fits probability distribution function, a PDF. Now, there are many probability distribution functions, for example, Weibull distribution, normal distribution, Rayleigh distribution, gamma, and so on. Depending on the site, you will have a kind of data. And depending on that data, one distribution could fit better to the data than another one. In particular, it turns out that Weibull probability distribution is very good for many sites. So we will focus on this distribution because of that. But this analysis can be extended to any distribution that you want. So, for example, I show you this graph where it shows a histogram of the wind speeds and how this Weibull distribution accurately fits the data. And just to remind you, analytically, this distribution takes this form where V is the wind speed, and there are two factors that are the ones that tell you the shape, the height and the width of the distribution. And these are namely the scale and the form factor. In the particular case where K is equal to 2, this distribution, this Weibull distribution, takes the form of the Rayleigh distribution, which is also very well known. And the mean speed is given by the scale factor. So depending on the mean speed at the site has a quality. For example, if we have a small wind speed, hold on, lots of air is coming into my wind and I should close it before. I'm sorry. Okay, now it's okay. So depending on the mean wind speed, the site has a quality. And for example, if the mean wind speed is of 4, it says that the quality of the site is not acceptable. As it is increasing, for example, from 5 to 7 up to 9, the quality of the site is increasing and the class of the site is increasing. So for the purposes of this work, since we are interested in using small-scale wind turbines, we will concentrate on sites with moderate and perhaps even poor wind in order to see if it can be useful to solve our problem. And now, what is our problem? How do we want to use this wind energy to help the energy sector? Well, what we want to do is we want to use it in the residential energy sector. And before continuing, I will just tell you relevant facts about the residence sector in Mexico. How does it work? Resident sector, what I mean by that is the energy in the households, okay? And the energy on the households has a price that depends on many factors. In particular, I will tell you the example, which I don't know why my screen is like a bit bigger, but well, this example is how it was working in 2016. Now it's more complicated, but for the sake of simplicity, let me focus on this one. And how does it work? Depending on where you are, there is a mean average, at an average temperature in the summer. So depending on that average temperature, which is given in this row, the price of the energy that you consume has a certain value. So for example, if you are in a place and located in a place in Mexico where the average temperature in summer is 25 degrees, then they say that you are, as a user, you belong to this kind of classification, which is tariff 1A, and it has a price. If you are in another place, for example, in the north of Mexico, which average temperature is, I don't know, 32 in summer, then you belong to this tariff with a higher price. So depending where you are located in our country, due to the location, there will be an average temperature in the summer. And then depending on that, you will be in one kind of tariff, and depending on the tariff will be the price. So that is how it works, or how it was working in that year. Now, the government was helping in the price of the energy if you were a consumer that, let's say, that was consuming a small amount of energy. If at some point you wanted to consume more energy, then the government said, okay, I will not help, I will not give a subsidize, and then you will have to pay the full price. So the government set these limits on energy consumption, kilowatt hour per month, and then if in a household you were consuming more, for example, than 400 kilowatts hour per month, then you automatically were entering in a high energy consumption tariff, and then you were paying more than that. By more, I mean twice or even more. So as long as you were not exceeding this limit, you can get a reasonable electricity bill. But if you were consuming more, then you were entering in a high consumption user tariff, and you were getting a very expensive electricity bill. Now, what happens? You know that Mexico is a place where the weather is kind of warm or hot, particularly in the summer. So in the summer, in places where the average temperature is high, of course, there are many people that turn on air conditioners, and you know that they consume a lot. So there was the problem that then the electricity bills were very high. Then we were thinking, okay, there are some places with this problem for the households, but also they have a moderate or poor wind resource. What if this wind resource could be used in order to produce the excess energy such that the user does not have to suffer because of the high price of their electricity bill. So that is the problem that in this particular work, we wanted to deal with it. Therefore, we construct a system for the assessment of wind power for residential use in order to avoid expensive electricity bills. And what are our ingredients? Well, we have to keep in mind two things. First, that wind speed constantly changes over the year and over the day, and therefore that's why we need a statistical treatment of it. But on the other hand, the electric energy demand is also constantly changing, so it also needs a statistical treatment. Many people, if you want to make a fast analysis, they can take mean values, and then things are very easy. But we wanted to make it, statistically, because that is the price of the energy in 2016. But then nowadays, the price does not only depend on the mean average temperature, it also depends on many other things, like when does the summer start and ends, which month of the year you are taking into consideration. And so there are more factors. And in order to know if it is a good idea to install a small scale wind turbine, you have to make a very detailed analysis about it. So that's the question. Given these two facts, is it possible that the wind turbine in these places help us or help the users not to get in a high domestic consuming regime? And then in our system, what we use as entries are the intermittent nature of the wind energy at each site and the uncertainty on the electric demand at each site. So these two are together in the system. All the information is together in the system, and the system evaluates what's going on using Bayesian intelligence. So let me open a parenthesis and tell you a few words about Bayesian intelligence. What is Bayesian intelligence? Well, first of all, it is a technique from artificial intelligence. That's the first point. Second, Bayesian intelligence is the ability for probabilistic reasoning. And as I said before, we are dealing with a statistical problem, and then this technique is ad hoc to deal with these problems. Now, few more words about this Bayesian intelligence. This is based in Bayes' theorem. Bayes' theorem, I remind you, that represents uncertainties through conditional probabilities. Basically, it tells you the probability of one variable, the conditional probability of one variable given the another one. Okay, so this tool from artificial intelligence is given on this, is based on this, on conditional probabilities. And but what is that? Well, Bayesian intelligence is basically a network, which is called Bayesian network. And this network is a graphical model that represents variables, which are the nodes, this node and this node. They are variables, and they are connected by the conditional probability, the conditional dependency between each other. So your problem, you can model it in a graph, which tells you how all the variables are related by conditional dependencies. Okay, so the nodes are all the variables, which are the observed quantities, and the edges are the relation between them, which are conditional probabilities, and analytically they are given by probability functions. Moreover, if you want to include utility functions, because perhaps you are dealing with a problem that involves decisions, like in this case, then you can build also a Bayesian decision network. And this is precisely what we did. We used this tool from artificial intelligence to model our problem. And then our machinery is the following. We have our Bayesian decision network, and the input is the wind speed PDF at each site. And on the other hand, the energy demand PDF at the site. And then the output is the technical feasibility that wind energy is able to cover the excess energy such that the user does not enter into a high consumer regime. Now, more in detail, what is the network? Well, this is the network I presented to you. So it's very easy to understand. Let me go through it. First, we have the city, the site that we're interested in, and then there is the distribution of the energy consumption at that city. There is also the limit on the energy. You remember, if you do not exceed that limit, then the government helps in the bill. But if you exceed that limit, you become high domestic user, and then the government does not help you, and the bill comes high. And so it depends on each site, this limit on the energy. And here we also have the wind speed distribution, okay? From here, we can calculate the distribution of the exceeding energy. Why distribution? Because remember that this changes over the months. And then we have to see if this quantity, if this energy, we have to see if the wind power that we generate is equal to this energy in order that the wind power provides this energy. How do we do that? Well, we consider as an example, two kinds of wind turbines, one of 5 kilowatts and another one of 10 kilowatts. We incorporate the power curve of each of them, and with the wind speed distribution, we are able to calculate the distribution of the produced energy. Then we are able to compare this distribution of the produced energy with the distribution of the energy in excess, and then we are able to see if it is possible or if it is feasible to avoid becoming a high domestic user using the small scale wind power. To apply this, we consider the cities in Mexico. And here you can see the city, you can see the mean wind speed, and you can see the factors that fit the speed resource at the site, and you can see the kind of tariffs, okay? On the other hand, here you can see the distribution of the energy consumption for each of the cities. And also here you have the power curves, the experimental power curves that we took into account for the 5 kilowatt and 10 kilowatt wind turbines. So we put all together, we programmed this network in a software that is called Nethica, and it looks like this. And what is the outcome? Okay, so here we have the results in this table. Look, this table tells you first the city we are considering, then the mean consumed energy every month per month. Here is. Then we have the excess on the energy in order to become a high consumer. And then we have the difference. So for example, in this case of the city of Puerto Peñasco, the mean energy per month is 2,710. I think I have almost reached the time. I'm almost done, sorry. The limit is 2,000. And so we see that there is an excess of energy of 710. Okay. On the other hand, here we have the estimate produced energy by the wind turbine of 5K. And here the wind turbine, the energy produced by the wind turbine of 10K. So here we see that we have 791, and here we have 1,264. So this is more than the excess energy. So yes, here, if we make the analysis deterministic, only taking into account mean values, we see that, yeah, it solves the problem. But our system, which takes into account all the distribution and the probabilities and everything, he says, okay, yeah, if you consider the 5K, you have a 57% probability that you will solve your problem. And if you consider 10K, you will have 63.9% that you will solve it. So at least in this case, everything is in accordance. But of course, this is a more accurate answer because it's a probability, you know, everything is a distribution. For example, so the green ones are the ones that they are positive and they will solve the problem. On the other hand, Tampico, here is the mean energy consumed per month. This is the limit and this is the excess. And this is the estimated energy per month produced by the 5K. And this is the one by the 10K. So we see that this is less than this. Therefore, this is not good here in this place. It is not a good idea to install the small scale wind turbines because they will not solve the problem. And indeed, our system tells us that the probability of solving is only 29%, and for the 10K it is 37%. So it is an agreement. But let's see this case, San Luis Rio. Here we have the mean energy per month, 3,710. The limit is 2,500. So we have an excess of 1,210. So if the wind turbine produces this for the 5K and for the 10K this, if one makes the analysis, you know, deterministic, only taking average values, one would say, no, it is not a good idea to install it here. But on the other hand, our system tells us, hold on, no, there is almost 60% probabilities that it works if you install 5K. And there is 64 probability, 64% of probability that it works with a 10K. So what's going on here? Why in this case the results do not agree? And the answer is very simple. The answer is that in this case, in this particular city, the distribution of the energy consumed all over the year is very spread. So when you have very large distributions, then if you take a mean average, it's not good. It can give you bad results. So on the other hand, if you have a narrow distribution, then it could give you a good answer if you just make a deterministic analysis just by taking average. So we have to be very careful with this because you see that here the treatment must be statistical, and in particular if you have a very large distribution. So let me conclude. I'm running, I'm sorry. Here we find two things. First, wind energy and also solar energy, but okay, we are focusing on wind energy. They have an intermittent nature, and therefore it is more appropriate to have a statistical treatment. And in this kind of very complex problems, because imagine that now we are dealing with the price of the electricity as it is nowadays, much more complex, then you cannot solve it easily, you know, just with average and conventional ways of doing it. So a technique from artificial intelligence is very useful. And in particular, we use this Bayesian intelligence technique, which is basically probabilistic reasoning. So that's it. Thank you so much for your time. And if you have any questions, please just ask. Thank you.
Thank you very much, Monica. It has been really interesting. And I'm sure that there will be some comments or questions for you. Emmanuel Dawn, do you have a question or comment?
Yeah, thank you for the presentation. Sounds very interesting, and yeah, it sounds like a very interesting use case due to the billing method in Mexico. The question that I have is considering the wind speed input, like what data do you take? And yeah, like you calculate some probabilities, but yeah, if you talk about the built environment and turbines close to the consumer, then of course, like there can be a huge difference in the wind speed. And yeah, that's the question. What data do you use as input for your model?
Yeah, thank you, Emmanuel, for your question. Yeah, in our case, for example, in all the cities, we look for wind speed data, which were 10 minutes wind speed. I mean, it was two years of data of wind speed recorded every 10 minutes all over the year. So that's the data we use for it. And for the energy demand, we look at the government. It has some pages where you can look at the energy consumption and in every site. And also there, you don't have every 10 minutes, unfortunately. You have only monthly values. And so we consider the energy consumed at each site per month over 2 years, and then we made the histograms. And from there, we get the probability distribution functions for the wind resource and from the energy demand at the sites.
So it would work for just one specific site then where you measured the data, since it could be completely different, like 5 meters away or 50 meters away from the point you measured.
I'm not sure. I don't think it changes. You mean if there is a station located, I don't know, for example, here, and you mean 5 meters away from the station? That's what
yeah, that was my consideration. Like the model seems very complex and a lot of calculation work. And then, yeah, for me, it was then just interesting what to use as input data, because this already is the quality is poor or for a site, then it's of course the model. Yeah, the result of the model also isn't really beneficial then.
I think it doesn't vary so much. If we were thinking about the height, it will be vary more. I mean, there are these cities that we took into consideration, there are small places. And actually, of course, you have to see if there are obstacles there, because if there are obstacles, yes, the wind speed may change over the distance. But okay, assuming if you want, we can make it more on detail, no? Or more, yeah, I mean, on detail. But assuming there are not big obstacles, we can consider that over that small city, the wind speed around, you know, the surface is more or less the same. But it doesn't matter, because even if there is an uncertainty of that is taken care of in the probabilistic treatment. On the contrary, if you were taking mean values, as I show in the table first, you know, contrast the results, in the mean value, of course, you are not giving any spot for uncertainties. And here in the probabilistic treatment, since I'm not saying yes, 100% or not, but I'm just saying 57% possible that it solves the problem, I am given a spot for uncertainty, which could cover this, for example, no? But as I said, usually if there are not obstacles around, we can consider that the wind speed is the same. Of course, it changes with height, but here we are taking the same height. And there are small scale wind powers, so they are not very tall, no?
Thanks.
I would like to stress the point that you have some advantages and disadvantages when you use the meteorological forecast or history. They give you the data of like at the height of sea level or up to 10 meters above the ground.
Okay.
And since you are dealing with urbanic areas, you may have weakness when you are dealing with busy neighborhood environment on one hand. So as Emmanuel consider or thinking of is the change of variations between point to point. But you have an advantage when you are looking for skyscrapers, which this is the trend. Then you may have a big advantage. If you're talking about 100 meters, 200 meters, you are talking about a factor of 2 relative to the annual history. So I think in favor of your work, you could always give a marginal calculation of this point.
Yeah, that's true. And also, indeed, in the cities that we were taking into consideration, you know, the houses, they're not, for example, it's not like in downtown in Mexico City where you can find very tall buildings or so. No, there actually are kind of small houses and things like that. But yeah, of course, I'm totally in agreement with you. Thank you. Someone else wants to ask something else?
Hi, thank you for your presentation, Monica. I have a question about if you there in Mexico have any metering system in the legislation right now, and how is the architectural design to the building integration wind turbine? You have thinking about around these topics or no?
Perhaps one of my colleagues, which is here, Javier, perhaps he can help me to answer that question. If you please could open the microphone to Javier.
Thanks, Monica, but I'm afraid that I am not sure if we have something like that in Mexico now.
Okay, or perhaps Raul, which is also around, because about the how did you say, Alexander?
Regulation. It's
regulation.
because
I don't know.
regulation.
Perhaps Raul knows.
No, don't have data for that now. Sorry about that.
Let me look for it, and if you wish, I can find out the information and send it by email. That's the best I can do right now.
Okay, thank you.
Thank you.
Here in Dominican Republic, we have the net metering in the legislation to incentivize the renewable energy deployment in a small scale. But now we have near 200 megawatt in PV solar system to the 1.5 megawatt below. It's very disseminated to the local system, but okay. With the small wind turbine, it's no appears nothing officially yet.
Okay, all right. Thank you for the information.
Sorry.
That's a question from Javier.
Yes, well, maybe I misunderstood the question, but in Mexico we have schemes to integrate small renewables to the grid. We have net metering, net billing, and another additional scheme to sell all the electricity produced by any renewable in Mexico.
Thank you, Javier. I think there is another question from Garrett. I see there its hand raised. Is it correct? No. If someone else has another question or comment, is more than welcome.
Well, it seems not. Or
there is a hand. I don't know how to pronounce it. Biarti. Thompson? No. Okay, no, there is nothing. I think there is nothing. So thank you so much for your invitation and for your time and for your attendance. Thank you.
Thank you very much for your contribution. It was very interesting and seeing about how things are possible and net metering and so on in Mexico. So thank you very much. We hope that we can use your presentation afterward. It will be sent out.
No problem. Yes.
And there, of course, there will be an email address to you if there are further questions people want to have answered. Well, thank you very much, Monica. The session for today is finished, and we will continue tomorrow at 11:25 CET. That means 25 minutes past 11 Central European time. And we will continue tomorrow with a session of education and start with the small wind turbine engineering using IEC. And that will be Sveni Enevoldsen who will performing. Well, thank you very much for today, and I wish you a good evening, good afternoon, or good morning, wherever you are in the world. Bye-bye.
Thank you. Bye-bye.
Bye-bye. See you tomorrow.
Thank you. Bye-bye.
Thank you, everyone.
Thank you. Bye.
Hasta mañana.
Thank you.
Adios.
Everyone.